Hello, welcome to my presentation on HRP program. I work on development of gesture-based applications, specifically video player control using deep learning models, which has been trained hand gesture recognition. Um, Utilization of hand gestures to control electronic devices has become one of the widely studied research topics in recent years. And in this HRP research, we plan to develop an Android app specific for video player in which we're going to utilize deep learning based gesture recognition to control the functionalities of the video player. For example, pausing or playing the videos, skipping backwards or forwards, increasing or decreasing the volume without actually touching the screen, just by waving and forming various hand gestures in the air. Not only creating the app, but having user-friendly design and publish-ready UI is also one of the objectives of ours. Because this type of application can allow users to control videos even if in circumstance where the device is not reachable by the users or if they prefer not to touch the device. So let's get started from the background. So in this work, we're actually using a deep learning model that has been trained in my previous research program, RNA. So the method that we used to make the model the last year was designed two-stage type architecture, where in the first stage, segmentation done, and there's a and then in the second stage, there's recognition of gestures, convolution neural network classification, like CNNs. An overview of the method is shown in this figure one. As you can see, at the first stage of the network, we did segmentation using TensorFlow image segmentation model. And in the second stage of the model, we trained the classification model with the OHANS dataset, which is available publicly in the internet, which contains RGB images of hand gestures and their corresponding segmentation. So this is the overview, and that's the model that we used. And so in this research, we plan to deploy model to a video player, a simple video player, by using Java language in Android Studio. We will include play pause. Specifically, we will include play pause, volume up, volume down, skip forwards, and skip backwards control to run the hand gesture based on the video player. We plan to make simple video test our model and is efficient in real time for playing, controlling a video. This approach will allow us to verify the aspects of the model that need to be modified or improved for deployment and application. This allows us to pinpoint the issue that need to be solved by constructing hand gesture recognition model that performs accurately under various environmental changes and in short elapsed time. So we hypothesized in the beginning of the research and began to implement some solutions to overcome the present issues. As far as notice, the model takes 2 or 3 seconds to recognize the hand out from the background, which is actually too long compared to the real-time application. So also, OHAN's dataset only contains the left hands of a person, which may pose an inconvenience to the user who's right-handed. To allow application to be conveniently used, we need to accommodate both hands. So we also plan to take an action on solving an elapsed time issue is by training the model with the OHANS data, same OHANS data set, but utilizing lesser classes. We choose specifically classes that are applicable to the real life, because class contains some gesture that is not really, which are really awkward to do in real time. So, and that method allows us to modify the structure of gesture recognition model to reduce the number of parameters. So, which of course results in overall size of the model. Additionally, you might change segmentation part of the model in the end if that is the last option to do. Instead of TensorFlow model, we can change for other models which are easier and cheaper than the currently have. And also, since model can only recognize left hands, we need to retrain the model to recognize right hand. So in order to do that, we do all data augmentation before retraining the model. to generate the right hand, to mirror the right hand, so the model can recognize right hands as well. So that's our methods and procedures to take in this research. So what I've done so far, so what we have in the result is that the hand gesture recognition model deployed on a mobile environment to see how a model work in a limited computational environment and examine the classification results. So as you can see from the table, each class has been classified with very good accuracy. So currently, we developed the video player application incorporating the hand gesture recognition model. Up to this point, we have developed our a simple video player, which includes all the necessary functions: play, pause, volume up, volume down, skip forward, skip backward, which of course skip forward, both of our 10 seconds. And you can see from that in our figure 2. We'll comment that later. So right now, the video player is controlled by just using 2 classes. Specifically class 0 and class 1, we are respectively corresponds to play and pause, as you can see from the picture. Nevertheless, in the end of the research, we're aiming to make it to include more sophisticated functionality such as resolution change, speed and brightness control, turning subtitles on and off, and locking the screen, etc. Also, notice that the model takes around 115 and 200 milliseconds to recognize the gestures. And the results, these results have been obtained in a Galaxy S21 device. Next plan now is to train the model with the needed gesture classes in order to decrease the model size and make it more optimized for a device that has less computational power than we used. Also, while training, we thought we should use a depth-wise separable convolution instead of normal convolution layer, since the depth-wise convolution offers much more light model, as the studies and research suggest, and you can see that we will include that in our report. Moreover, since we need to model in a model which recognize both hands and will do augmentation before fitting the dataset to the model, like I said before. And lastly, if there is any need of they detect gestures are dynamic in nature, such as waving the hand or swiping left or right, I think we will modify the model structure a little bit to recognize the analyze and sequential set of images. The possible approach include for that long short-term memory, which is LSTM, or recurrent neural networks, RNNs, which are known to get high performance. So as a conclusion, last research on developing hand gesture-based deep learning model for mobile devices enabled us to go further and deploy it on mobile applications, specifically on a video player. So in this research, we are gonna use that model and improve the video player functionality, such as play and pause, volume up, volume down, skip backwards and forwards. So in doing so, we saw potential issues within development. Firstly, the model has been trained that the only contains right hands, and the last time recognize the hand to specification takes longer time than required in real-time application. To overcome those issues, we propose some procedures and additionally propose make the app user-friendly, which will be the whole purpose of the research. At this point, we have only developed simple video player deploy with the model, but next step is to deploy the lighter version of the model that's enough to perform the real-time analysis of the hand gestures. Thank you very much.